In this video, we're gonna play around with loops. I'm gonna make a while loop, and then I'm also gonna make a for loop, which does pretty much the same thing except all in one case. We rarely will use while loops, but while loops can be useful in certain cases. So here's what we'll do first. So first, I'm gonna create a counter integer. So I'll say int count, and I'm going to start it out as 0. So I'm declaring it and initializing it in the same line. And then I'll start my while loop. So while there's some condition, so there's some condition inside those parentheses, always open and close, and while open and close before I even start doing anything. So it's saying while something, keep doing this stuff on the inside. So let's see what happens here. So while count is less than or equal to 10. Let's say that. And I'm going to start it at 1. So here we go. So let's see. So it should be, well, we'll see. System.out.println. What is that noise? All right. Okay, so system.out.println. Let's just see what happens. I'm going to print the count is, and then I'll put that number, count. So the first time this runs through, well, actually, I'll write it out and then I'll explain what's happening. So this is, and then count plus plus. So let's see what happens. So this count has 1 stored inside it. And then it's saying while count is less than or equal to 10. Well, right now, count is 1. So this is true. Count is less than or equal to 10. So it'll enter this while loop. And since this is true, it'll go down to this line and it'll print out the count is, and the first time it prints, it'll say 1. And then it'll go to the next line. Count gets incremented by 1. So now, after this is executed, we have the number 2 stored in count. And then it checks this condition again. 2 less than or equal to 10. Yes, that's true. So we'll print this out. And it keeps going until count gets to 11. And we can see if count is 11, then it'll check this again. Count less than or equal to 10? No, because 11 is not less than or equal to 10. And then it'll stop executing this loop. So it'll continue this loop until this is not true. So let's see, let's compile this and see for ourselves. The count is 1, the count is, so it goes down all the way to 10. So that's a while loop. It's fairly straightforward. If you forget, watch this. I might have to close everything. If you forget this, there's other compilers that allow you to stop the running of the program if you have an infinite loop. Some compilers check for an infinite loop. This, I mean, everything compiles fine, but if I run it, count is never changing. Like count is 1 right now, and 1 is always less than or equal to 10. So this will run and it'll just keep going and keep going and keep going. So I'm going to break this right now. Actually, I don't want to break it yet. I'll break it at the end. Count plus plus. So that's a while loop. I'm going to create a for loop that does the exact same thing, except for I'm going to call something else. I'll do something else. So let's comment this out, and then edit comment. Okay, so that's done. And then I'm going to do a for loop that does the exact same thing. So for, and then some things, open curly brace, close curly brace, just good style, and for. Before I do anything, I always type out my format. That way I never forget to close it, and I don't close it in the wrong spot and you get all these weird errors that I don't understand. So for a for loop, really I initialize a variable, I write the condition, and I do the increments all in the parentheses right here. So I do all 3 of these things. They're crucial parts of a loop. The initialization, the condition, and the incrementation. incrementing, whatever. So what I'm going to do is I'm going to say int. I'm declaring a variable int. It's called count2, just so it's not the same as this. Count2, and then I'll start it out. It's 1. I'll start it at 1. Usually you start at 0, but well, I'll start it at 0 then. And then I put a semicolon. That's important. If you don't do a semicolon, it won't execute properly. So count2 starts at 0, and I'm going to say it's kind of like, okay, initialize, and then while count2, so this is the condition part, count2, and instead of saying less than or equal to 10, if I wanted to print out 10 times, I would say less than 10. Why? Wait, this will print out 10 times? Yes, it will, because we're printing out the 0 case all the way up to the 9th case. If you count 0 as a thing, 1 as a thing, 2 as a thing, 3, 4, 5, 6, 7, 8, 9, that's 10 things. That's 10 iterations. Just we're starting at 0. And then semicolon. So the initialization, the condition, and then the incrementation. So count2 plus plus. And that's it. You don't need a semicolon at the end of that one, I don't think. And then we'll say system, we'll do the exact same thing. Except for this will be count2. And now it should go 0 all the way through 9 because I have less than 10. So compile, close, run, 0 to 9. So that's while loops and for loops. There you go. Let's break it now. Suppose, well, I'll comment this out. Hold it. Comment. And then I'll uncomment this. Okay, so if I forget to increment my counter variable, it compiles fine still. It just never stops because there's no way this condition will always be true because count is always going to be 1. So I compiled, close, watch what happens. This will happen a lot, and you'll just have to close everything. So run it. The count is 1. The count is 1. It's actually continuing to go. I should have changed it. I should have changed something. Now I can't even close this. I have to close it that way, but it's still running in the background, so I'll eventually have to close everything. Everything. Let's fix this. So what do I want to do? I want to say count. Let's change this. I want you to see that it's actually not just stopping there, so I'm going to change this a little bit. Count, we'll say, this will be count 1. Count 1. And up here, int count 1 gets 1, or 0. Okay, so this doesn't have anything to do with my loop. My loop conditions are about count, which is 1, and it's always going to be 1. Count 1, though, oh, that's confusing, I'm going to increment that. Count 1 plus plus. So now I should be printing out just 1 through infinity, pretty much, if the computer could just go on infinitely, but it can't. So if I did this, this number will change, but this number will not change. So we'll be stuck inside this infinite loop, I think. So let's see. Let's see. Yes. And it just keeps growing and growing and growing and growing until you get to the biggest integer that the computer can do. So now, and we're stuck, and I can't even close it. So I have to close everything. So those are loops. I'm going to be done.